All right, so today is not in the book, if you have a book at home. So today is like a little bonus lesson for this chapter 10. We're going to learn two special formulas that help us find the area of any triangle. And that means like any triangle, and you don't even need the height. So right now you think that the triangle's formula for area is base times height over 2, or 1/2 base times height. So we have special area formulas, and that's what the title of today's lesson is, special area formulas. So we need the semi-perimeter, which is half the perimeter. So F plus G plus H all over 2. All right, and then the area of this triangle, according to Heron's formula, is the square root of S minus F times S minus H times S minus G. And we also need an S out front. So Heron's formula, the square root of S times S minus F times S minus H times S minus G. So you take the semi-perimeter and you multiply it by the semi-perimeter minus all 3 of the sides of the triangle. All right? So it's wonderful when you know all 3 sides. So similar, remember when we know all 3 sides, you can always use law of cosines, law of sines. It's nice when you have an angle, okay, because you know that you cannot use sine, cosine, and tangent unless it's a right triangle. So, but Heron's formula works for any triangle when you know all 3 sides.
I don't know. I felt like it.
So this Heron's formula works for any triangle, even a right triangle if you wanted to. Okay, next one is just fun to say because it's Brahmagupta's formula. So everybody say Brahmagupta.
Brahmagupta.
All right, so for Brahmagupta, we need the semi-perimeter as well. Okay? However, this is only for, this is important, this is only for a quadrilateral that is inscribed in a circle. So here you got the quadrilateral, and it's inscribed in a circle, meaning every one of the quadrilateral's vertices is on the circle. So Brahmagupta's formula only works for these types of quadrilaterals that are inscribed in a circle. Okay? And what we want to do is we want to find the area of them. Okay, so the semi-perimeter then, I have 4 sides. So you just have to do T plus U plus Z plus W divided by 2. It's half of the perimeter. We good?
Yeah.
All right, now on Brahmagupta's, the area of the quad, it's the square root of, the difference is you don't put the S in front, and that's the only difference. So it's S minus W times S minus Z times S minus U and S minus T. And we just asked earlier, like, does the order matter of which sides I use? And the answer is no, because order does not matter in multiplication. All right, so again, it only works for quadrilaterals that are inscribed in a circle. Very important. Heron's formula, any triangle you want. So what I would like you to do is I'd like you to try example 1. Ready, go. All right, so for number 1, am I going to use Heron's or Brahmagupta? Brahmagupta, because it's an inscribed quadrilateral. So you could draw the picture if you want to, but it's not needed because you know it's inscribed in the circle. So I first find little s. So if I add up all the sides, you get 6, 17, is it 26? So 26 divided by 2 is 13. So according to Brahmagupta, the area of this quadrilateral is 12 times 8 times 4 times 2, and then I take the square root of that, which is approximately 27.71 0.71 centimeters squared. Okay? All right, can you go ahead and find example 2 and example 3? See if you can get both. Ready, go. Okay, catching up with you. This is definitely not a right triangle, 4, 5, 7, because the Pythagorean theorem does not work on that, right? What kind of triangle is it, though? 4 squared plus 5 squared, 16 plus 25 is? 16 plus 25 is 41, and that is less than 49. So this is it's obtuse triangle because the 7 squared is bigger than the 2 other legs squared, right? Little review for, okay? All right, so now the semi-perimeter then, since I want to find the area of this triangle, is 8, right?
Yep.
So then the area of the triangle by Heron's formula, which I can use for any triangle, is 8 times 4 times 3 times 1. Right? Which is the square root of, 32 times 3 is? 96, and you can give me the decimal, which is 9.79. Okay, I think 96 does reduce. Right? How many times is 4 going to 96? Okay, so how about 16?
6.
Okay, so this would be 4 root 6. We good? All right, now, this one. Okay, I knew that some of you would start doing Brahmagupta here. However, I did not give you the circle to show that this figure was inscribed in a circle, and I also didn't say it. So you can't assume that it is inscribed in a circle. All right, so what you needed to do was draw this hypotenuse, because this is a right angle. Since that's a right angle, I know that that hypotenuse is 15. So then what you wanted to do is find the area of each one of these triangles and add them together. So what is 1/2 of 9 times 12? Okay, so the area of this triangle is 54. Now I need to find the area of this triangle. And that one I can use Heron's formula. Okay, so the semi-perimeter of the black triangle is it 18?
Yeah.
So the area of the black triangle, by definition of Heron's formula, is 18 times 3 times 8 times 7. Okay, can you tell me what's underneath the root, please?
3,024.
And the square root of that? 3,024?
54.99.
54.99, and then you will add to it to find the total answer, which is 108.99 inches squared. All right? So that one, you cannot assume that it's inscribed in a circle. All right. And that's all, folks. You can work on the day 2 worksheet. Ready, go.